Section 5.5 is on inequalities in two triangles. So this is the hinge theorem thing that I just talked about. So we just said if you have two sides that are the same, so this marking and this marking, and then like this marking and this marking, you can imagine that those two sides are like sticks or straws or whatever on a hinge. And so when you open them up, the side across from them is bigger if the angle across from it is bigger. So if this angle is the smallest angle, this is the smaller side. If this is the bigger angle, this is the bigger side. Okay, so we're imagining it on a hinge. So let's see if you guys got these questions right. So we have measure of angle 1 and measure of angle 2. We're relating these two angles. Since I have a 10 here, but I only have 7 here, we want to look to see if our sides are the same. So see how we have our set of sides that are the same there, but then we have a shared side there. So imagine our sticks or straws or whatever we have. Across from the 10 is going to be the bigger angle. So this one's the big one, this one's the small one. Is that what you guys had? So if we relate them, we would say the measure of angle 1 is greater than the measure of angle 2. That would be a way to relate them. How else could I have phrased that? The measure of angle 2 is less than the measure of angle 1. I don't care which way you do it. All right, so same idea here. So first identify if we have two pairs of sticks that are the same, right? So we have those two sides that are the same, and then we have the shared middle. So we have a blue and a red for each of those, right? So across from it, if we had the big angle, we have the big side across from it. If we have the small angle, we have the small side, right? So if I'm comparing my ZB and my XB, XB was the one that was smaller than the ZB. Okay, you don't need the lines over them because these are talking about lengths. So we'll just do XB is less than ZB. All right, so did you guys get those for the first two? Pretty easy, right? Okay, so then the next ones, look for the sides that are the same. So we have an 8 and we have an 8, right? And then we have another side that's a shared one. So across from it we have 5 and 9. So 5 is smaller than 9. So that means that angle 1 is the small one, and angle 2 is the big one. So we should have measure of angle 1 is smaller than the measure of angle 2. Right? And then same thing for this one. So we have 16 and 16. And then we need those other two like sticks equal to each other, right? Do you guys see where we get them? Yeah, we get them because we have an isosceles triangle, which means that these two sides are the same. Okay, so we have the red and the blue again. So in between those red and blue lines, we have a distance of 5 and a distance of 6. So that means angle 3 has to be greater than angle 4. Okay, does that make sense? The measure of angle 3 is bigger than measure of angle 4. Oh wait, I messed it up, didn't I? Measure of angle 3 is smaller than, you didn't even say anything, you could have gotten a bonus point. Measure of angle 3 is smaller than measure of angle 4, right? Because measure of angle 3 was across from the 5, the smaller one. All right, good? Did you guys get all those? All right, so that part's the easy part, right? These got to be a little bit harder. So part of the hard part is that it's not really pointing very easily, or not pointing very well to what it should be pointing at. So that should be there. Does that help? Okay, and then this 14 should be here. All right, so we want to describe possible values for x. So we want to look for sides that are the same. So we have 7 is the same as 7, and we have 6 is the same as 6. So if we're comparing our angles, we have 102, and we have that 7x plus 4. Which of those two is greater? Is 102 bigger than 7x plus 4, or is 7x plus 4 greater than 102? What do you think, Cam?
7x plus 4 is greater than 102.
Yeah, 7x plus 4, since it's across from the bigger number, well, it's across from the smaller number, right? So 7x plus 4 has to be smaller than 102. So it has to be like that. Because the side length that's across from it, we have 8 versus 12, right? So 8 is smaller. So this one's going to be the small one, and this one will be the big one. Okay, so that creates an inequality. If I subtract the 9 over, I get 98. 7x is less than 98, so I get x is less than, I believe, 14 if you divide that out. All right, and then are there ways to, you know, get another inequality? No, I don't think so in this case. So we're going to look at the other one. So I want to again look for the sides that are the same. These are kind of hard sometimes when you're taking a test and they're mixed in with other problems. It's hard to recognize that you're supposed to be doing this. But we have a red side and a red side. Do you guys see that we also have a shared side? So I'll make that one the blue one. So we have angles that are trapped between the red and the blue. So if you need to use highlighters or whatever, you can use highlighters on your test. So this 14 degrees versus the other angle trapped is 56. So the 14 is the small, right? So across from it we have the smaller side, and across from the 56 we have the bigger side. So when we write our inequality, we have that 11x minus 12 has to be smaller than 54. So I have 11x is smaller than 66, which means x is smaller than 6. Okay, so we get an inequality. So sometimes you might have more than one. So maybe you have another way to relate x using two other sides, right? So maybe you get x's trapped between like 2 and 6, right? Or just x is bigger than 2 or x is smaller than 6, right? Does this make sense? Okay, is that a pretty easy section? Can you guys handle that? All right, let me pass out your homework.